The hive looks still. From the outside, it appears abandoned, like they're in hibernation. So how can an insect that can't survive cold temperatures make it through months of winter without freezing? Inside, tens of thousands are doing something very unusual. As temperatures drop, the colony abandons the idea of individual survival. The bees stop behaving like separate organisms and begin functioning as a single system. They form a dense cluster around the queen. What's important here isn't warmth in the way humans think about it. Bees don't heat the hive like central heating in a house. They focus on heating the cluster itself, not the whole hive. Worker bees in the centre vibrate their flight muscles. These are the same muscles used for flying, but now they're being used purely for heat generation. No movement, no flight. Just rapid muscle contractions, converting stored energy into warmth. That heat spreads outward through the mass of bodies. So if the bees are constantly burning energy to stay warm, but where do they get their energy from? Let's come back to that in a minute. Bees on the outside of the cluster act as insulation. They press tightly together, reducing heat loss to the environment. As they cool, they slowly rotate inward, swapping places with warmer bees from the centre. The cluster behaves less like a group of insects and more like a living heat engine. Think of it like tending a fireplace through a long winter night. The fire isn't roaring. There are no flames climbing the chimney. Instead, the heat is concentrated at the centre. Too much fuel and it burns out too fast. Too little and the fire collapses. So the logs are shifted slowly, carefully, keeping the core alive without wasting energy. Each bee is acting like a single log in that fire. No one controls the flame, but together they maintain it. But if they are burning all of this energy to stay warm, why don't they starve before winter ends? This is where you can see how smart they really are. Food still matters. Throughout winter, bees consume stored honey to fuel this heat production. If the reserves run out, the system collapses, even if the temperature control's perfect. And the queen, she stays almost completely still. She isn't laying eggs, she isn't directing anything. She's simply being kept alive within the narrow temperature range that allows the colony to restart when spring arrives. Here's what makes this unsettling. If the cluster breaks apart for too long, the heat balance fails. If too many bees die, the insulation thins. If honey runs out, the fire goes cold. And if that balance slips just a little too far, it shuts down.